Good morning, my YouTube viewers. It is Crystal here, and I'm just here this morning because I want to do a code review, and I'm doing a code review on a data set that I made and I put together. This is a real-world data set. It's to do with a department and a nonprofit organization, and basically you have the number of employees, which is on one column, and then you have the training deficiencies on the other column. And so what we're going to do is we're going to use VAR to try to make a prediction on the number of employees and the training deficiencies. So every month it will be different. And basically what happened was this data set, the information in this data set was compiled over the COVID-19 pandemic. So during that time they stopped training because they just had to work on the pandemic, and they stopped doing recruitments. They changed the way they did recruitment. So instead of having recruitment open days, they were using agency staff, and then if they liked agency staff, they would take them on permanently. So they also changed the way they did recruitment. So that's two things that they changed during this period, how they do training and how they do recruitment. So without further ado, we'll go ahead and look at how we have predicted on this data set using vector auto regression and stats models. Okay, so the first thing we want to do is we want to import our libraries, and we've got quite a few libraries that we have to import in this instance. So we're going to import pandas, which is a data processing library. It creates data frames and maintains them. We're going to create NumPy, which is a mathematics numerical library. It enables you to create NumPy arrays, and it also enables you to perform numeric computations, and it also enables you to perform linear algebra. We're going to import math, which performs mathematical calculations that are not in the standard, well, it is in the standard Python program. We're going to import matplotlib pyplot SPLT, which is a graphics program that points all of the data points onto a graph. We're going to import Seaborn, which is a higher level graphics program than matplotlib. It's written on the back of matplotlib, and it enables you to do statistics along with your graphics. We're going to import date time, so because we need to do some date manipulation, because the dates that I put in, I put the information in Excel, and even though I put the information in Excel, it didn't go over very well. Oh, excuse me, it's early in the morning. It didn't go over very well, so we had to use the date time function to try to manipulate the dates. We imported sklearn, which is a machine learning library. It's a great library. I really like sklearn a lot. The documentation on this library is very good too. And we're going to import statsmodels, which is a statistical library. We're going to import TQDM. I'm not sure exactly what that is, but we're going to import it. And we're going to import itertools, which helps us to iterate. Excuse me. It's early in the morning. And after we've imported all our libraries, then what we want to do is we want to load our CSV file. Now this CSV file is a file that I made, but I loaded it onto Kaggle. So if you want to use the CSV file, if you go, I think it's under Analyse Training. Let me see if I can find it. See datasets. your work. So I think I've imported 3 data sets so far. So it's called Analyze Training Deficiencies. So yeah, so far I've imported 3 data sets that you can look at those data sets and use them if you want them. Use them if you want to use them. So it is on Kaggle. And so yeah, if you want to use the data set, it's there on Kaggle. Okay. So we've got our data set, and I've already showed that to you. So it says that df equals pd, that's pandas.read.csv, and then I personally loaded the data set into my drive, and it says parse dates equals month, and then so it had originally been set up to where the index column was the month, but whenever I did this data set, I did it in Excel. And so Excel has a certain way that they do the month and the year. And the way that Excel does the month and the year is not necessarily what Python wants to see. So I couldn't make it the index. I had to make the month a column. But we will make it an index in the program. So here you can see we've got month, no, number employees is called no_employees, and training underscore deficiency. So no underscore employees is like number of employees. And you can see this spans from January 20 to July 22, which is a year and a half. There were 2.5 years really, because it's 30 rows of information. And so you started out with 132 employees and you ended with 131. And so it's just changes from month to month. But what they're doing now, what they had done at the beginning of the pandemic, was they were having recruitment open days. And so they would wait until they had a few vacancies. And then when they had a few vacancies, they would have a recruitment open days. But they stopped doing that. Now what they're doing is they're using agency staff, and then if they like the agency staff, they'll take them on permanently. So they changed the way they've done recruitment, and you can see over here that they had a lot more training deficiencies in the beginning during COVID. Because they weren't doing any training, they decided that they were going to discontinue training during COVID. And so they had a lot more training deficiencies during COVID. And then it's really gone down. And so basically what has happened is there's been a lot of changes. Obviously, I can't talk about too much about this organization, but I will say that they're having a big push on training now. We'll just put it that way. There's a big push on training. So what we could do, we'll rerun this, because what I want to do is so we're going to describe it. So we've got a count of 31 columns, 31 rows. You've got the mean, you've got the standard deviation, you've got the minimum, and 25%, 50%, 75%, and the maximum. So during this training period, the minimum was 164 and the maximum was 307. So you had a pretty big standard deviation between the minimum and the maximum, and that's why I wanted to rerun the program. So you can see, now you know a little bit about this data set because it is a real world data set. Okay, now since this data set was, I did it in Excel. What I did was I did it in Excel and I saved it as a CSV file. I had to manipulate the data, which is sad. It would be nice if Excel was compatible with Python, but it's not. Other than the fact that I can save it as a CSV file. So df mon equals df month, and then you use a string of the first 3 characters. Df year equals df month, and then you use a string of the 4th character to the end. df drop month, so we're going to drop the month and then df. So now you have number of employees, training deficiency, month, and year. And so we had to do that because unfortunately Excel dates are not compatible with Python dates. And then so df month year equals df month plus 20 plus df year. So now we've got df month year. So now we've got another date that's what Python wants to see. df month year equals pd to date time df month year. So we convert it to a date time object, and you can see when we do df.info, you can see month year is a date time object. So we're going to make the index the date now. df index equals df month year df. So you see that we've got that index. So now we're going to drop mon year and mon year because we don't need that anymore. So df.drop mon year, axis equals 1, in place equals true. So you can see we go back to the data frame. So mon year is your index, and then we've got our 2 columns of data. So we graph it, so you can see that the employees was pretty stable, but the training deficiencies, there's a wide variation in the standard training deficiencies, and so that shows that they had a large standard deviation. So now we do the Dickey-Fuller test. So let's just see here. So that's what we're doing. We're doing the Dickey-Fuller test. In statistics, the Dickey-Fuller tests the null hypothesis that a unit root is present in an autoaggressive time series model. So that's what your Dickey-Fuller test is. And so basically, I used a for loop because I got the for loop from somewhere else, because sometimes you don't know, how many columns of data you're going to have. So I did this based upon the fact we didn't know how many columns of data we were going to have. And I watched another YouTube video and they just did it the same way with the 2 each column of data. But doing it with a for loop really is better because then you're not having to do the same thing over and over again. So for I in range, len df columns, result equals AD fuller df columns I. If result 1, because your test has a result with 2 numbers on it. If result 1 is greater than 0.05, print series is not stationary, df columns 1 result, and then you say result equals AD fuller df I block, then 1, and then you difference it. Because they do differencing methods to make it stationary, and you print adjusted result by differencing df columns I result 1. Else print series is stationary, df columns I result 1. And then when we finish the for loop, when you get and then when you finish the if-else statement, you print ADF statistics for DF columns I result 0. Then you print p-value for DF columns I result 1. And so you can see the results as it iterates through it. So there's 2 columns of data. So the first column it goes through number of employees. It says series is not stationary. Number of employees is 0.35. And so that is more than the 0.05, which they want. So you had to use differencing to adjust it. So differencing is just one method that they can use to adjust it. And so you've got the code for differencing there. So adjusted result by differencing is number of employees 0.002. So that adjusted it to less than 0.05. And then now we say ADF statistics for number of employees is -3.85, and then the p-value is 0.00235. And then it iterates through the next one, and it says series is not stationary, the training deficiencies is 0.5, and then adjusted result by differencing is training deficiencies is 4.2, so that actually made it worse. So I'm not really an expert on time series, so I don't know what you do when you difference it and it's still greater than 0.05. I'll have to do a search and find out. So ADF statistics for training deficiencies is -5.82. And then p-value for training deficiencies is 4.2. So that's still greater than 0.05. And I'll have to look on the internet and find out what happens when you do your differencing and it still isn't less than 0.05. So it's not stationary. Now we do the Granger casualty test, so we can do it here. So Granger casualty test, it's a non-parametric test. Granger casualty test is a statistical hypothesis test for determining whether one time series is useful in forecasting another. So that's interesting. That's another test that you can do. And then so I got the code for this Granger casualty test somewhere else, and instead of putting it in a for loop, he just did it one after the other. So I could go back and do a for loop on that and see what happens. Maybe I might do that. Okay. So there's your Granger casualty test. And I think that's probably a little bit more difficult to put in a for loop, because in this instance we only had 2 columns of data. So I don't know if you had like 8 columns of data, what you would do. I mean, I'll have to research that. But this is the first time I've done a vector auto regression. And so I wanted to do a code review on that. And I worked on it for about 2 days. It was quite frustrating because there's not a lot on the internet about VAR, especially when you go through the tutorials. Sometimes the code doesn't work, and then another thing that happens is that they're not going to give you all the code, because if they give you all the code, then you'll know how to do it. And so that's what I found out when I was researching the internet. They would give you some basic things, but then when it got to actually forecasting, they didn't give you the forecast, especially if it's a business making a website. That's what I found out. And so I had to resort to looking at YouTube videos and going through the YouTube videos and then looking at them and then trying to find out what the people on the YouTube videos did. I didn't get the information by looking at tutorials on the internet, not at all. So we're going to create a data frame with features to be used. We're going to have 2 features, number of employees and training deficiencies. So data equals DF, number employees and training deficiencies. Data shape is 31 rows by 2 columns. We're going to split the training data frame up into training and testing sets. So train length equals int len data times 0.8. So our training set is going to be 80% and our testing set is going to be 20%. Train data equals data 0 to the train length. Test is data 0 the train length to the end. And then we check our train shape and our test shape. So our train shape is 24 rows by 2 columns, and our test shape is 7 rows by 2 columns. We're going to select our model. It's going to be VAR. That's going to be vector auto regression. So model equals VAR, train, frequency equals MS. So the frequency is going to be on the month. And I will say this, that the documentation for the stats models is quite ambiguous, and I find the documentation for stats models a lot harder to understand than the documentation for sklearn. And as a result of that, I think a lot of people don't know stats models that well. They know sklearn much better because sklearn has great documentation. I love sklearn. I love puttering around in that library. Stats models is more difficult to use. You have to do a lot more research, because stats models doesn't give you that much example code. They give you a little bit of example code, but not that much example code. Now we do something called sorted order. Sorted order equals model.select order 3. And then so this is another thing that you have to work on. So if it's a small data set, you have to make sure that the select order is a small number. If it's not a small number, then it won't work. And I had to find that out by researching the data set. So as I said, I've worked on this problem for a couple of days. And since I worked on the problem for a couple of days, I was really exhausted yesterday, trying to find the problem, because you're not going to get the answer to the problem looking on these tutorials on the internet. I found the solution to the problem by going through YouTube videos, and then even quite often the YouTube videos, the code doesn't work either. So you still have to troubleshoot. That's what you have to do. So we can see you print your sorted order summary. So this is your sorted order summary. And one thing that I found out watching a video yesterday was you look at the asterisk. If the number has an asterisk on it, then that's the number that you need to use. That's the number that you need to use. So look and find out where the asterisk is and that's the number you need to use. So we do it again. Model equals VAR, train, frequency equals MS, results equals model fit 2, because this is what we're using right here, the number with the asterisk on it, because that means that's like the most optimal lag. You know, print results summary again, so you've got your results summary. So this is our results summary. They give you a nice little table, a nice little printout. A number of equations is 2, knobs is 22, log likelihood, AIC, and then it gives you your L1 and L2 because we had 2, and it gives you coefficient, standard deviation error, T statistic, and your probability. And obviously, I'm not a statistician, I'm studying statistics, but I'm not perfect on that, so I can't not, like decipher the summary for you bit by bit, but there you go. So we've got the result for number of employees and the result for training deficiencies, and then you've got your correlation matrix of the 2 columns of data. And now what we're going to do is make predictions. So making predictions is where, when you're looking on the internet, you're going to have the most problem, because whenever you're going through the tutorials, they stop just short of making predictions. They get to the point where you can print out your summary, but they don't give you the predictions, and that's what I want, is the predictions. So you do have to be careful when you're looking at tutorials, because quite often the code doesn't work. They don't give you all the code. Because they don't give you all the code, you can't do it. And so that's why I figured this out just watching YouTube videos. So lag equals results.kar. Predictions equals results.forecast, train.values to the negative lag to the end, and steps equals len test. So coefficient equals PD data prime result params, number employees, result p-values, number of employees. So then you get your coefficient. And it gives you some information, but I'm just wondering here, because we did the number of employees, but we didn't do the training deficiencies. Okay, just one second. Well, I think what I'm going to do is I'm going to just leave it, because if I change this, then it's going to change everything else. So I'll just leave it for the time being. So coefficient.columns equals coef p-val. So you've got your coefficients, you've got your number of employees, and you've got your training deficiencies. And then coefficient.query is p-val is less than 0.05 NP where coefficient p-val is less than 0.0510, so it gives you an array. Then coefficient valid is NP where coefficient p-val is less than 0.0510. And so these are like some more tests that I got from someone who knows a lot more about time series analysis than I do. And then you've got some more coefficients. So coefficient.arr equals coefficient 1 to the n, the p-values. And then so what you do is you get an array with 4 rows of data. You get your coefficient ARR, you've got your 4 rows of data. Then you've got your train neg lag to the end. So that's month, year. This is your training data. 1 November 21 is number of employees is 127 and 213. And 1 December 2021, number of employees is 129 and training deficiencies is 208. And then NARR equals train neg lag to the end, and then the data set -1 dot stat your 2 frame t values, and then you check the shape and it's one row of data, 4 columns. NRR is an array, so you've got your 1 row of data with your 4 columns. Now we do our dot product, so it's getting into statistics. NP dot NARR coefficient ARR plus colon 1 dot values is an array of 129.180. So that's pretty, so if we come back here to our forecast, let's see. So 129.180, so that was your first one. So there you go. So we can compare the predictions to the actual values. So we've got our predictions equals, we convert it to a data frame. And then so basically we did a graph on that. So you can see how the training deficiencies changed over time, but the number of employees didn't change that much. And you calculate your errors. So the error for the number of employees is 3.29, and the error for the training deficiencies is 64. So, but what we didn't do is, I'm just going to come over here a second. I'm going to copy and paste some code. I hope this works. hope this works. Let's see. Try it again. Hmm. So you got that. So that's where it's not working. It's not working on predictions. So it's working on tests. It's just not working on predictions. Okay. Let's try this. Okay, so let's give this a go. Let's see what happens. There we go. So you can see, you can compare, now what you can do is you can compare the number of employees to the actual to the predicted. And now what we'll do is we'll do the training deficiencies. So I guess that's a good thing for me to do the code review, because if I do a code review, then if I do a code review, then I can find out things I could have done better. Let's try this. So now you can see the training deficiencies, the actual training deficiencies, and the predicted training deficiencies. So you can see that the predicted training deficiencies are greater than the actual training deficiencies. So it didn't do a very good job on training deficiencies. And then so now we've got our chart. So you can, it was supposed to chart 4 values, but for some reason it only charted 3. So, sorry, it only charted 2. So that didn't turn out very well, but that's the actual chart that it gives you. And then it says calculate errors. And it said the errors for the number of employees was 3.29, and the errors for the training deficiencies was 64. So the number of employees, it did a much better job than the training deficiencies. But that's VAR in a nutshell, vector auto regression. And so we had a real world data set that I prepared in order to do this, and so you can see what it's like. So I'm going to go ahead and conclude this video because it's been going on for 42 minutes, and I hope you got something out of it. As I said, I'm not an expert, but I'll tell you, give you all the information that I had, and it was a good thing that I did do this code review because I can make a few little changes to it. So thank you so much for supporting my channel. If you like this video, please like, subscribe, and share. And thank you so much for watching this video, and I look forward to making more videos for you in the future.